All right, let's take a look at our first percent yield question. Here we're asked for the percent yield of hydrogen fluoride, which is a very toxic chemical. We note that the percent yield is always the actual yield divided by the theoretical yield. The actual yield is what we obtain in the lab, and the theoretical yield is what we predict using stoichiometry. In many respects, the percent yield measures the efficiency of a process, and there are many reasons why your actual yield may not equal your theoretical yield. Side reactions, recovery issues, for instance, the iron copper lab that you did, you might not have been able to scrape out all the copper from the beaker. That's an example of why your percent yield would be less than 100, but it has to be between 0 or 100, so keep that in mind. You also generally will be given the actual yield in the problem. So here we note that we've actually recovered 2.09 grams of hydrogen fluoride. So what's left for us is to predict the theoretical yield using stoichiometry. So let's go ahead and do that. Fortunately, in this problem, we're told that we have an excess of sulfuric acid, so there's no limiting reagent. We could give you a limiting reagent problem within the context of percent yield, and the theoretical yield would be the maximum amount predicted by the limiting reagent. So let's calculate our theoretical yield of hydrogen fluoride, and this should really be old news by now. Moles of calcium fluoride to moles of hydrogen fluoride. And this is something that we've done before, so I don't necessarily think we need to go over it. Just remember to pay attention to the stoichiometric ratio, 2 moles of hydrogen fluoride for every 1 mole of calcium fluoride. And what this answer is telling us is that we could produce 2.95 grams, paying attention to significant figures, so that should be 2.95. We could produce this amount if the reaction were 100% effective, but it isn't, and we'll calculate the percent yield on the next slide. So we know that it's actual over theoretical, and we can plug in the values. So we get an answer that is about 71%. So that means that this reaction is approximately 71% efficient. Not bad, but not great either. And of course, it is slightly dependent on your process too, and the reaction transformation that you're trying to accomplish. So good luck.